So, how do filter matrices work in convolutional neural? Before this, I want to show you that how the CNN sees the image. So, you know that the images that we use in our real world, for example, the image of a car, these are nothing but just a set of numbers. That is 1 1 1 1 1 1 1 1 1 for wheels, and for the boundaries 1 1 1 1 1, and rest of them are 0 0 0. So you see that these ones are a black pixel. So they are forming an image of a car and rest are zero, so white ones. So on a white background, this is the black colored car outline. So this is the image that you see, and this is how it is stored in a PCs or laptops, any type of distribution systems. So how does the CNN work? So to identify if the image belongs to a car, of a plane, of a human. Now, how will your brain interpret this? I want to show you this. For example, this is you. So your brain will use a window. It will divide the whole image into different windows. A window for wheels, a window for the hood, a window for the rear, a window for the front, and try to in each window whatever feature it found. In this window, it found that the wheels are circular. In this window, it found that the rear is slanted, so it must belong to a car. So you divided the whole image into small regions, and then using your own knowledge, you cross-checked this in knowledge stored in your brain, and came to the conclusion that okay, this image belongs to a car. The CNN works in the same way. It also divides the whole image in the form of numbers into different windows, and using the features extracted from these windows, it cross-checks it with the labeled information or whatever information the user has given in form of supervised learning, and then the model becomes trained to identify any type of sophisticated information, any type of image data set. Okay. So how are these windows formed this convolutional neural networks? So windows in CNN are formed by something called as filter matrices. I will give you the reason that why it is a convolutional neural. So what are these filter matrices? These are nothing but small matrices, usually of odd shape like 3 cross 3, 5 cross 5, 4 cross 7, usually very small. And they have a value, for example, 1 1 1, 0 0 0, 0 0 0. So what are these values? For example, take the image of a car. I just told you that it is in the form of numbers, right? And this filter matrix, okay, this is the form of a number. Now, in form of image, can you imagine how will it look like? If the one is a black pixel and the zero is a white pixel, it will look something like this, right? A simple black vertical stripe or vertical edge. Now, what does this filter has to do with the CNN? And why did the CNN make this filter method? It made this because it wanted to detect the vertical edges in the image. Where are the vertical edges in the image? Here, 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 and here. Four vertical edges. And these four vertical edges are actually the windows. The CNN actually goes through the whole image, and wherever it detects these prominent windows with these features, then it stops. And in the output, it makes these features quite prominent, and the rest of the non-prominent features are very light in nature or very distorted in nature. So the final output of the after the CNN has worked on after the CNN use this filter matrix of vertical type 1 1 1 0 0 0 0 0 0 on this windows, these features have become prominent. And using this, the CNN understands, okay, these features are present here. Similarly, I need to find the horizontal edges, and then it combines all these information to understand that this is the image of a car because of the already and already stored information in the brain of the cell, in the backbone of the cell. So this is why these CNN filters are important. They actually are the windows, small windows that help to detect different features in different regions of the brain. And these filters are filter matrices can be a different type, can be a vertical edge, can be a slanting edge, even can be a partial circular curve type structure, anything. And when all these are combined, you can see that then it can detect different type of very complex features in the input image, CNN. And that's why CNN is a more powerful form of deep learning model that I've ever encountered in vision transformer payment system. So, and these values, they are actually the weights of the CNN, and they have come after a lot of training over the label data. Like for example, if you want to identify the image of a car from a bike, over a lot of training by giving different sorts of images of the car to the CNN model. It learns these with the shapes and biases that are to be used to identify the image of the car. Okay, this is how filter matrices work. And this operation, that how the filter matrices know this is a prominent feature. For example, in this region, what will be the feature here? 111.2.2.2. Because these are very lightly inside. I'm talking about this region. In the input image, this will look something like this. As in this filter matrices, 111. Now, how will it know that this is important? It will do an element wise multiplication. 0 with 0.2, 1 with 1, 0 with 0.2, again this. Each element is multiplied with its corresponding element, WI, PI, and then we do a summation, and whatever value we get. Now you know that there is 0, 0, 0, 0. So all this will give 0, this will give 1, and the final value will be 1, 3. So this makes the CNN know that okay, in this region, since a non-negative value is present, so this feature must have been present in this value. And in the output image, I should make it more prominent. So this final value of 3 is shown here. That's why it's more darker than this 0 regions final output. And this whole dot product of element-wise multiplication and then addition operation is known as convolution operation. Convolution actually means combining two different signals to make a third signal. The two different signals are combined to make a third signal. That's why it's known as convolution operation.